And next on the stage will be Pavel Kulha from company PROFACTOR, and he
Hi.
will giving presentation about concept for direct integration of electronic circuits and sensors on textiles using inkjet printing. So Pavel, the stage is yours.
Thank you. So my name is Pavel Kulha. I work as a senior scientist at PROFACTOR. My responsibility is basically development of inkjet printing processes towards realization of either interconnections or printed electronics on various substrates. So today the presentation will be more focused on textiles, but as a first I have to introduce PROFACTOR as well. PROFACTOR is a small research company located in Upper Austria. Meanwhile, we have over 100 employees working in various of topics. We are basically a publicly owned company. Our owners are AIT, which is largest research institution in Austria, and Upper Austrian Research, which is agency for stimulation of research in Upper Austria. Most of our turnover is coming basically from funded projects, so we basically cooperate with many partners or on really various levels of cooperation, from bilateral projects to big European projects. But of course the focus is to develop certain technology which are then transferred to industry. So as I said, our company has different departments which can be divided in two main groups, let's say. One is industrial assistance systems, which basically deals a lot with robotics, so robotic movements, human-machine collaboration, flexible robotics, and machine vision. And the second is basically additive, micro and nano fabrication, which I belong to, which is further subdivided into group which deals with micro and nanostructures and their replication using nanoimprint lithography. And my topic is basically printed electronics and also integration of electronics into 3D objects. There is also one joint venture between those two bigger groups, and this is robot-based inkjet printing. So we have an equipment which can print on large objects using robotic arms. Yeah, for sure, there are other technologies which can produce can be used to produce printed electronics. We are exclusively focused on inkjet because our group is relatively small, and we simply cannot cover all the technologies, despite maybe and there would be advantages. So we use inkjet printing with all the advantages and disadvantages which are clear. The disadvantages are mainly on the material level, because the viscosity range for inkjet is relatively low. We are limited with particle size and so on. Despite of this, we think that the inkjet approach is kind of technology also for future, kind of, because it's a digital technology. Basically, what we are printing is just question of image, so we can change the image from 1 second to another, from one product to another. We don't have to replace anything in the pilot line, for example, or the printer. We just load another picture. That's the advantage. The inkjet printing can be multi-material, so the scalability and using of multi-material is basically a question of number of print heads which we want to print, or the materials which you want to print at once or sequentially. And this approach has also advantage that it has 3D capability and in principle scalability, because the size of the printing bed is just a question of number of heads which are placed next to each other. Within our projects, which we are either coordinating or we are part of, there are several subtopics which we are dealing with. One is chip integration and packaging by additive manufacturing, which means we are handling of bare dies, printing of fan-out structures for bare dies, assembling of them, and so on.